So, of course, my name, it's written there, Kadir, and I'm the tech lead for SRE here in Berlin. So, let's get started. My first question would be, just to get like a feel of the room, is who heard of Canary Deployments before? Okay. Who knows how it works and how you would do it? Okay, that's awesome. It's just one person. Cool. No, really, now I'm even happier because it's something new to teach. So the idea behind Canary Deployments is if you have a new application version which you want to deploy, right? There's multiple strategies which you can pursue. Some traditional ones are blue-green, rolling. You can even do like a binary swap, like pull everything on the new version. You can do it gradually, like some percentage to the new version. That's quite good, but how do you detect that the new version is now not working? Well, the traditional approach is that you put somebody before the monitoring and like he looks, right? Until the deployment finishes, he looks, and even after, yeah. So that's a good solution, but also quite time-consuming. We at Kadir have about 200 microservices, so at one point in time it gets a bit intensive, like time-consuming. So there's a better way, and that is essentially Canary Deployments. The idea behind it is you put, again, similar to the rolling deployment, one instance with a new version, and put a small amount of traffic to that. So until now, very similar. What you do now is you essentially try to replicate a statistical setup. That means similar to drug testing and other tests like in science, you try to make it so that you can test with statistical tools significance that the new version is now worse than before or not. How does that essentially work? So if you want to test something, if something is broken or not, it's hard to test the code. Like, is the code now way worse than before or not? It's really hard, but what you can do is essentially every code has a ripple effect on the matrices, right? So you might write some code which is now increasing the CPU load, right? So it has a ripple effect on a lot of matrices. Memory, if you now save a lot more things, it might also affect HTTP status codes because now you're a bit harsher, a bit stricter on things. So everything you write has some effect on values like matrices. And what we're trying to measure is if these values, if these matrices get now worse in an automatic manner. We don't want people sitting before the matrices and looking at it. What we want to do is to kind of find that out automatically. So that's the general idea. How does it even work? I have stolen this picture from this blog. It's really nice. So, but what we essentially do is normally we have production running, right? And this is a gray box here at the top. The moment we want to test a new application version, what we're gonna do is we are gonna deploy a new version, right, on a new environment. Now a lot of people will ask, like, why do you have like this baseline? It's the same version as above. As you can see, it's the version 1 in the production, and then the baseline is also version 1. Why do you even do that? You want to compare the old version against the new version, right? So we have already one old version there. Why do we do that? And it's quite simple. Old environments, old instances behave differently than new ones. If you start up, the cache has to be warm, right? It might be there's a memory leak, so like the memory is higher on old instances than new ones. There's a lot of things which behave differently if your machine is already running a week or even just 2 hours. So the best way to compare two things which should be the same except the application version is to start at the same time, to have the same setup. What each of these applications now do, each of these environments, is to send their matrices to some storage device. It might be Prometheus, New Relic, Stackdriver, whatever you're using. It doesn't matter, to be honest. The only important thing is that you will be able to later on differentiate each of these environments in your metric itself. So you kind of need to label them somehow. Cool. So there's a few rules. If you want to really make sure that you are able to detect that automatically in a statistical manner, what you need to make sure is that every other side effect, every other variable which can influence your deployment is taken out of the picture. So, if you, so there's a few rules, I just try to list them, is when you take the baseline and deploy it, you have to use the current production version. Because if you don't, you're kind of comparing apples and bananas, something totally different. So you deploy as a baseline the current production version. The Canary gets a new version. So quite now, very simple. The baseline and the Canary should be deployed at the same time to have the same conditions from the start, the same preconditions. The baseline and the Canary should also use the same infrastructure code, because it might be that if you have a different infrastructure code, it might be that it's like using different environment variables, something else. So that would be really ideal. The only difference really should be the application version you're trying to deploy. What you also need to do is route the same amount of traffic to the Canary and the baseline. Because if you route now to the baseline more traffic, well, it has a higher CPU probably, right? Or different matrices. So you really want to equalize all other parameters, and just the only difference should be between the two versions, the version, like the application version. And of course, it's implicitly given, it should be forward and backward compatible, because otherwise you couldn't run a new version and the old version at the same time. If you need to do some database migrations, you cannot run well, you cannot run the new version at the same time as the old version. So to kind of sum it up, really, if you equalize all other variable in your deployment and only the app version is different, then you can do Canary deployments. So a lot of people, like this came a lot in our company, and they were asking, why not use weighted DNS, right? And well, in the beginning, I was like actually pursuing that, like we should probably keep it simple and just use that. But DNS is not made for routing. Okay, it is, but not in the scale we want to use. So how does DNS work? Let's go very shortly into that to explain why it's not suitable. If you want the same amount of traffic, right, on the Canary and the baseline, it has to be really the same. Otherwise, statistical tests can be quite sensitive. So if you get just a bit more fluctuations on the Canary or on the baseline, it might look like it's different, but it's not. So let's go into DNS. So essentially, if you have an upstream service and it's asking for a specific machine, and in this case I called it foo service my domain, what the DNS server essentially is giving you back is all the IPs which are related to that DNS and the weights. Now the client chooses one of these with the probability of the weight. So in this case I have 90 and 10. So he would choose with a 90% chance the first IP, which would be 10.551, or with a 10% chance 10.552. What he does now is he keeps that IP, the one he chose, let's say he chose the first one because it's more probable, keeps that in mind until the TTL expires. So he will, if it's 10 seconds, he will keep it for 10 seconds in his mind. All traffic goes to that IP, to that single IP, right? So now you have to ask yourself, what if I only have one upstream service, one machine which is querying that other service? Well, so the end outcome is essentially, you either give full traffic to that instance or full traffic to that instance. So there's no split, right? So it can be quite imbalanced, especially around the short term. If you like 10 hours, at one point in time, it will look like, oh yeah, 90% traffic, 10% traffic. But if you look short term, and this is essentially also very important, right? Because they will behave differently, this will not work out. I made some statistical tests to check when can we use DNS to do these kinds of routings. It's essentially around plus 1,000 instances. If you have plus 1,000 instances as upstream, that means you're either exposed to the internet and you have 1,000 customers, or you have a lot of machines internally and then you're using that. Only then you can use DNS. Please.
I think you're also not in charge of the DNS caching client, right?
I didn't even get into that. So DNS caching is super weird, as in even if you set the TTL to 10 seconds, we at like Karim sometimes even observed like propagation times of 30 minutes. So I didn't get even into that. So you're totally right. So the best way actually to do the routing, to come to the conclusion, is essentially use a load balancers. It can be Nginx, hub proxy, whatever like your poison is. Pick anything, as long as you can request by request routing, it will work. Do we have questions, Antonio? Awesome. Okay, is everything clear?
Yeah.
Cool. So if we have now this canary, right? We have the baseline of the canary. What metrics do we even want to measure, right? So if we go by the SRE book by Google, there's essentially 3 categories. One, latency. Second, errors. And the third one, saturation. Latency is quite obvious. It doesn't have to be, by the way, request latencies. There's some other types of latencies. Errors can be HTTP codes or exceptions in the application itself. And saturation is like how much utilization you have, either network, CPU, memory, whatever. Just to get into more explicit measures, you can, for example, with the request latency, you can go into the 50 percentile, 90, 90, 90, HTTP equals 400, 500 exceptions in the applications, I already said. And most importantly, actually, what I think is really powerful is custom matrices, right? If you have your service and you know that this one metric which you custom built has a lot of value about if the service is working or not, then that's a great metric. Use that one. The more you know about your application, more business logic, and the more you put that into that metric, which is a high correlation to functionality, the better the metric is actually for the canary analysis itself, the step later.
Have you got an example of a good custom metric that you
yeah, for example, we have something in Karim called the assignment ratio. So Karim is ride-hailing, so you kind of want a car, right? And then you assign it to a specific category. If some services are not working fine, that assignment ratio drops. Right? That's a very specific metric, but essentially it's showing if the system is properly assigning the drivers to the people, right? Others might be a number of, like if you have a system which kind of does promo codes, right? Is how many promo codes are in percentage true or not. That's another good one. Now it's quite important, right? To think about what does the canary analysis, the canary deployments does not measure. There's a specific subset. Let's go into the assignment ratio, right? You have your service, take that example, and the assignment ratio drops, but the problem is not it drops because of some of that service itself, but some downstream service somewhere else. That's perfectly fine. Because you equalized your setup, what happens is that this metric, in this case the assignment ratio, will drop in both instances at the same time. And because the metrics is essentially align, like they're the same, right? Like they should be moving in parallel, it's fine. The canary analysis only triggers if the old version, like the baseline, and the new version, canary, these matrices, like they kind of differentiate. So the matrices coming from that or that are really going apart. In that moment, yes, like you will find out something changed between the old version and the new version. Yeah. Let's go to the canary analysis step. So until now it was just setup, right? We kind of set all our scientific setup. We said, okay, we know like how to do which matrices. We have the matrices, we have the infrastructure deployed. Perfect. Now we get to the canary analysis step. Essentially what we're doing here is really statistics, machine learning, whatever you want to call it. So to do that, to do statistical testing, the best way is actually to know your distribution of the data. So if you know how your data behaves, you can use a very specific test. If you know like it's a Gaussian distribution, use a t-test. If you know it's To be honest, I don't know any other test, but there's different tests also for the power law, for like different ones. Essentially, if you don't know what you're gonna use an unparametric test, and that might be the Kolmogorov Smirnov or the Man-Whitney. But if you really know what the distribution is about, use a specific one. It's much better and brings you more significance and more value out of that. One very popular choice, which is always said, is Spinnaker. Like, use Spinnaker for doing canary analysis. You can use that. But to be honest, you don't need Spinnaker to just do the canary analysis step. If you want to do that, any statistical test will do, as long as you know how statistics works. And just pick your local data scientist, bring him on board, show him what you want to test, and you will be able to do that. And what you get out of that significance test, of the like statistical test, is essentially significance value, it's called, right? It shows how significant the difference is between the baseline matrices and the canary matrices. So what it essentially boils down to, I think I have it on the next one, yes. If it is not significant, it means that the canary and the baseline, from perspective of the matrices, are the same. So it might be look like you have to kind of swap. Like, if it's not significant, it's a good version. If it is significant, it means that the matrices diverge somehow. So you need to find out which matrix is different in the baseline than in the canary. If you find that out, you can essentially look why the matrix is now different. It might be totally legit. If you take something like CPU, or yeah, exactly. That's what I mean with use very good matrices. The more, if you use CPU, and let's say you do now more calculations, more checks, if the incoming values are really true. So you use more CPU cycles, right? That's totally legit, it's fine. But in that case, the canary might trigger if it's like getting into a significant part. So you might use like really increase the CPU, but it might be good that you do that, but it still will trigger. So you will not find, it's not magic. It's not gonna find every one of your issues. You should still do your tests. You still need to understand what's happening. But it will find things which you didn't expect before. Or if like you might look into it, yeah, of course, I did these extra calculations. Now I know, like I can give still this green light to continue deploying. But it might be also that you don't know, and you're like, oh, why is the CPU now like 20% higher? Well, let's look into that, right? So this is what's gonna happen with your application. It will trigger, and you need to find out why. Afterwards, you can still make the decision or not. So it's like a sign of like a last resort, like. And the cost, there's always a cost involved, right? If you deploy something to production, with even if you just use 5%, 1% of traffic, that 1% is still going to the riskier version of the canary, right? If you are not gonna do your test and just like kind of pipe everything to production, that extra 1% is gonna be affecting your customers. So it's really important, like there's a cost, you always kind of test on your customers. So just to say that, because there's also notion going on that, yeah, just use that and it's fine. If you wanna further read, here are some links. The first one is really good. It wasn't available until 2 months ago or so. So read that one if you want to really get some more details out of it. Here are some techniques how you can use that. The last one is if you want to just use like a simplified setup. So please, yeah, that's it.
Questions?
Yes, of course.
So my first question. So when you start to route the traffic, do you split the traffic or you mirror the traffic to different nodes? I mean to the second or third node.
Meter?
Mirror.
Okay. So you can also mirror. So the question was if we just split it or if you mirror. If you can mirror it, that would be even better. But mirroring is not always possible, especially with if your application is not, if it's changing the database or if it's changing other things, right? You cannot just mirror always traffic. But if you can do that, it's actually even better. Then you can kind of take the mirror traffic, put it to the baseline, put it to the canary and see how it behaves. Even better. Otherwise, the only option is routing traffic. So you would take 5%, 1%, whatever you want to take, and route it to the canary and to the baseline.
And don't you try to mirror traffic in your case?
In our case,
in how?
You can also mirror traffic. In that case, also you need some kind of proxy or load balancer front, which kind of captures the traffic and then mirrors it. But for Kareem, we don't do that because it's quite like there's so many variables which you kind of need to check on, like the Redis caches, the databases, and that's a really ideal choice. But often in the reality, you have a lot of baggage in your services, which you're like pulling along. So if you have very clean service, it works definitely. But if you have like services which are already 3 years old, that's kind of a dream. Like that's not possible. Yeah, there was some question. No? Okay.